You know that feeling, right? When the air just changes, the sky gets this deep, bruised color, and you can almost feel the energy building. It's awesome in the true sense of the word. Well, today, we're going to peek behind the curtain and figure out just what's going on up there. And then, when it all lets loose, you get this. That's a bolt of lightning, and it has an unbelievable amount of energy. It literally tears through the sky. It's gorgeous, powerful, and, yeah, a little bit scary all at once. So that's really the big question we're tackling today, isn't it? I mean, how does a perfectly nice, calm day suddenly turn into this swirling, supercharged spectacle? It's a really cool scientific puzzle. All right, let's get into it. So, the story of every single storm, believe it or not, starts with two really basic things: heat from our sun and how that heat messes with air pressure. This simple setup is the engine that drives pretty much all the weather on Earth. It all kicks off with the sun. And here's the thing, the sun doesn't warm up our planet like a perfectly even oven. Nope. Some spots get blasted with sunlight, others get less. So the ground warms up, and so does the air right above it. Now, warm air is less dense. It's lighter, so it starts to rise. That creates a pocket of low pressure. Well, something has to fill that gap, right? So cooler, denser air sinks down to take its place. That creates high pressure. This simple up and down dance is called convection, and it's going on all around us all the time. And here's the key. Nature is always trying to find balance. The air doesn't like having these high and low pressure zones, so it's always rushing from the high pressure spots to the low pressure spots to try and even things out. You know what we call that movement? Wind. Simple, right? But that one basic principle is the seed for everything from a light breeze to the most ferocious storm. Okay, so things are moving, but now we're going to add a new ingredient to the mix that really kicks things into high gear: moisture. When you add water to that basic weather engine, you unleash a ton of hidden energy. And that, my friends, is how you build a thunderstorm. So here's the recipe. First, you take that warm, moist air and you make it rise fast. As it rockets up into the cold upper atmosphere, that water vapor cools down and condenses, forming a cloud. But this is the magic moment. When water vapor turns back into liquid, it releases a massive amount of hidden energy. It's called latent heat. Think of it like a coiled spring suddenly snapping open. That burst of heat warms the air around it, making it rise even faster, which releases more heat. You see where this is going? Inside that cloud, it's just total chaos, with billions of water droplets and ice crystals smashing into each other. And all those tiny collisions, well, they turn the cloud into a giant static electricity generator in the sky. Seriously, the charges get separated. The lighter positive charges get lofted up to the very top of the cloud, and the heavier negative charges sink down to the bottom. The cloud has basically become a giant angry battery just floating up there. And when that charge difference gets too big to handle, zap! You get a massive electrical discharge trying to balance things out. We call that lightning. And the thunder? Well, that lightning bolt is insanely hot. It heats the air around it so fast that the air literally explodes outward. That explosive shockwave is what we hear as thunder. The reason you see the flash first is simple. Light is just way, way faster than sound. Okay, a thunderstorm is impressive, no doubt. But what happens when you take that same weather engine and give it a nearly unlimited source of fuel? Well, then you get something much bigger. You get one of nature's true heavyweights, a cyclone. The big difference here is the fuel tank. A thunderstorm over land might run out of gas, so to speak, but a cyclone is born over a warm ocean. We're talking water that's at least 26.5 degrees Celsius. That warm water is like an all-you-can-eat buffet of heat and moisture, the two key ingredients for that latent heat energy that makes storms so powerful. This is its lifeline. And this creates an incredible feedback loop. You've got warm, moist air rising, which releases that latent heat and creates this super low pressure zone. That low pressure sucks in even more air from all around. But because the Earth is spinning, that incoming air gets deflected and it starts to spiral. That new air gets warmed by the ocean, picks up moisture, rises, and makes the pressure even lower, which sucks in more air. And it just keeps feeding itself, spinning faster and growing stronger and bigger into this massive organized storm. If you could look down on a cyclone from above, this is what you'd see. You've got these huge, violent bands of wind and rain spiraling in toward the middle. But then, right in the center, there's this weirdly calm, often clear area. That's the famous eye of the storm. And it's calm for a fascinating reason. right in the middle of all that rising air, a little bit of air from high up is actually sinking. And sinking air means no clouds, no wind. It's this bizarre little pocket of peace in the middle of total mayhem. So learning the science behind all this is really cool, for sure. But it's also absolutely critical, because understanding how these storms work helps us understand just how dangerous they can be, and more importantly, how we can stay safe. Just to put that power into perspective, think about this number. During the 1999 cyclone that hit Odisha in India, the wind speeds topped 200 kilometers per hour. That is faster than you're allowed to drive on most highways. Just try to imagine that kind of force hitting everything in its path. Cyclones are really a triple threat. First, you've got those incredibly high winds we just talked about that can just shred buildings and trees. Second, you have the storm surge. The intense low pressure literally pulls the surface of the ocean up, pushing a huge wall of water onto the coast. And third, you have the rain, just unbelievable amounts of rain that can go on for days and cause massive flooding.
So knowing what's coming is everything. For a thunderstorm, the rules are pretty straightforward. Get inside, don't stand under a lone tree, and stay away from metal. Simple enough. For a cyclone, it's a whole other level. You need to get to a safe structure, have an emergency kit with food and water ready to go, and, this is the most important part, you have to listen to the warnings from the meteorological department and do what they say. Understanding the threat is the first step to staying safe.
When you step back, you can see how it's all part of one big story. It all starts with the sun heating the earth unevenly. That creates pressure differences, which creates wind. Add in some moisture and latent heat, you get a thunderstorm. Put that whole engine over a warm ocean, and you can get a massive cyclone. It's all connected. And here is the best part of this whole story. Our understanding of the science is our single greatest defense. We have incredible technology now, satellites, radar, that lets meteorologists see these storms forming from a long way off. They can track them, predict their path, and issue warnings 24 or even 48 hours ahead of time. That's precious time for people to prepare, to evacuate, and to get safe. It saves so many lives. So, to wrap this all up, I'm going to leave you with a thought. Now that you know about the incredible forces at play, from simple air pressure all the way up to the spinning fury of a cyclone, take a look outside. Think about the weather where you live. What's the most surprising or amazing thing about it now that you know what's really going on?